be looking at application of first order differential equation, so that from then we can learn how do we apply differential equation to solve the real life problem. So we call it application of linear differential equation. Application of linear differential equation. Let me share my screen so we can proceed from there. Can you see my screen now?
I can see it.
Okay, that's fine. So application of linear differential equation. So this application is we have it in population model, we have it in radioactive decay, we have it in Newton law of cooling. So Newton law of cooling, we'll start with the Newton law of cooling. Any of them that we can lay our hands on. For Newton law, let's start with the Newton law. Newton's law of cooling. So for Newton's laws of cooling, there are things we need to check, but let's write a short note in there. Newton's law of cooling states that the time rate states that the time rate of change of the temperature of a body is proportional to the temperature difference, is proportional to the temperature, let me just shorten like this, temperature difference between the body and its surrounding medium. Its surrounding medium. So in this case now, I said using Newton's law of cooling, derive a difference using a differential equation. for the cooling of a hot body surrounded by a cool medium. By a cool medium. So that I'm just laying a foundation now. Let T denote the temperature of the body, and let T subscript M denote the temperature of the surrounding medium. Surrounding medium can be in different space. It depends on where we are trying to consider. So let's take note of that. Then excuse me, some people are saying they are unable to log in. Why? Is it not the same link? Sorry, are we there now? Okay, then the time rate of change of the temperature of the body is the capital T over the small t. So the capital T in this case is the temperature is the temperature, while the T is the time change. So, and Newton's law of cooling can be formulated as the capital T, the small t, to be equals to minus k, where k is the positive constant, into T minus Tm, or as the T over the T plus KT equals to KTM. We call it equation 1. where K is a positive constant. Where K is a positive constant of proportion. Where K is positive constant of proportion. How do you log into the platform, please? Ajia. Proportionality. Are you there? Maimuna.
Yes, sir.
How do you log in? You just use the link?
Through the ID, yes.
Okay.
Through my ID, I went through that.
Through the Zoom ID?
Yes.
Or you use the link?
No, I use the Zoom ID.
Zoom ID, okay. Okay. So, of the constants of proportionality, okay, let's go on. Since K is choosing positive, the medium, the minus rather, the minus there, the minus sign in Newton's law is required to make the t, the small t, negative for a cooling process. Note that such process, note that such process know that such a process T is greater than Tm, thus T minus Tm is positive. T minus Tm is positive. So what do we need to do? How do we solve the problem? Let's look at the example. In this case. Then after that, we move to another subheading. Example in this case. Example 1, let's use this. A melter bar at a temperature of 100 degrees Fahrenheit is placed in a room at a constant temperature of 0 degree Fahrenheit. Zero-degree Fahrenheit. Sorry. 0 degree Fahrenheit. Then if after 20 minutes, the temperature of the bar is 50 degree Fahrenheit, find an expression for the temperature of the bar at any time. At any time. Find an expression of the bar at any time. So for us to solve this problem is very simple solution. Let's look at it. The first thing you need to know is the surrounding medium is the room temperature. Like I told you the other time, the surrounding medium will determine where they place something will determine. But in this case now, the surrounding medium is room temperature. Is the room which is being held at a constant temperature of 0 degree Fahrenheit. So Tm equals to 0. That is, remember what we call Tm from here. What do we call Tm here? I mentioned Tm the other time. If you check your notes, I said let Tm denote the temperature in surrounding medium. So we know the surrounding medium here is 0, which is this. Then, and the T, we don't have the T. The T equals to K in bracket T minus Tm becomes the small t plus kt equals to 0. Since it's supposed to be k tm, since tm is 0 here, so everything here will be 0. So in this case, we call this one, this is linear. It's a linear differential equation. So we can go ahead and solve this one. We call this one equation 1. First thing is to use separable variable. Remember, all t will go to themselves. So at the end of the day, we have here, when you multiply through, by dt over t, capital T. So what do we have? We have dt over capital T dt plus kt dt over capital T equals to 0. So here you see this one cancel this. So you have the capital T over small t, big T, plus temperature cancel the temperature, you have K dt equals to 0. So in this case now, remember the way we used to solve it. So we have integral of, this is 1 all over T dt, the capital T rather, equals to minus K dt. Take it to the other side. We know that 1 over T is ln T, capital T, equals to minus KT. I'm looking for the temperature. So if I take exponential of both sides, I will have exponent ln T equals to exponential minus KT dot exponential C. And exponential C is still exponential, is still C. Constant is still constant. Exponential will cancel ln. You have T equals to C exponential minus KT. Remember from the question, we were given 100 variable for that temperature. Since capital T is equals to 100, what do we have? At T, small t equals to 0. That is the initial one, the temperature of the bar is initially 100 degrees Fahrenheit, which follow, it follow that 100 equals to C exponential minus K of 0, or 100 equals to C. Remember, exponential 0 is 1. So 1 multiplied by C is C. So our C is equals to 100. So if C is equals to 100, we can now go ahead and look at what will happen. Let's say our T will now equals to 100 exponential minus KT, which becomes our equation 2. Now, the question go further. The go further says, if after 20 minutes, what happened? At small t equals to 20, we are given that t equals to 50. Since capital T, because it's there in the question, it said, if after 20 minutes, the temperature of the bar is 50 degrees Fahrenheit. So it's going to be, we're using equation 2 becomes 50 equals to 100 exponential minus K of 20. So that is the meaning. So exponential minus K of 20, that means we can now solve for K now. So let's see how to solve for K. So it's going to be 50 equals to 100 exponential minus 20. So now that we have exponential minus 20k, then we can proceed by saying that we can divide both sides by 100. Divide both sides by 100, you have 50 divided by 100 equals to 100 exponential minus 20k divided by 100. This goes with this. 1 all over 2 equals to exponential minus 20k. Don't forget we need k. We want to find the k. And the only thing we need to do is to take the log, take the log, or take the log, take the ln. Let's use ln. Take the ln of both sides. Is this the same thing as log? So if you take the ln of both sides, what do we need to do in this case? So we should just say ln 1 all over 2 equals to ln exponential minus 20k. So the ln we cancel exponential, you have ln 1 all over 2 equals to minus 20k. So by the time you solve the both side, you will realize that we need k alone. We can divide both sides by minus 20. If you divide both sides by minus 20, you have minus 1 all over 20, ln 0.5, and punch your calculator, equals to k. So if you do it very well, our k is equal to 0.035 from your calculator. Therefore, the temperature of the bar at any time t is then t equals to 100 exponential minus 0.0535 rather. 0.3 0.035 t, equation 3. Any question, please? Are you following me, Mona? So in case you're given another question, same question, under the same question, they now ask us to find they ask us to say, okay, to now give us find the time it will take for the bar in the equation 3 to reach a temperature of 25 degrees Fahrenheit. But recall that, so we're solving this one now. Recall that T t equals to 100 exponential minus 0.035t. Then our capital T in this case is 25. So we substitute it here into equation 3. Then we have 25 equals to 100 exponential minus 0.035t. So if you have this one, you have it to be, which implies 25 divided by 100 equals to exponential minus 0.0535t. So in this case now we have 1/4 equals to exponential 0.035t. We are looking for t. So we use the same method the earlier one we use. Take the lane of both sides, because lane is the only thing that we can use against exponential, or exponential is the only thing we can use against lane. So either two. So 1/this will give us lane exponential 0.0. This is minus 0.035t. So at the end of the day, we are very close to the answer. So we have this one to be negative 1.3538 rather, upon 3863. This will have cancelled this. Equals to negative 0.35035t. So when you divide both sides by 0.035, so this is what we have. So at the end of the day, when you divide this side, it's a t. The negative cancel negative here. T is equals to 39.6084 minutes. Are we there? Memuna, are you there? Can you hear me?
I can hear you, sir.
Oh, okay. Can you get the board? Yes. Any question? Any question? Any question, please? Should I proceed?
Yes, proceed, sir. No question.
Okay. Okay. So if you look at your textbook to your course material, you have some things similar in there for this particular example. But now let's look at the population. One is talking about population. How do we use a differential equation and population in this case? For the population, or for the population model, I will not go into detail. So I will give us, how do we formulate? You can read your books for the detail in there, but let's look at this population. model. Under the population model, we have the P over the T equals to Kp over the Kp. So where K is equals to growth of the population and P is equals to population size. Of the population size so how do we calculate this before we solve the problem? So what we need to do is separable variable. This is differential equation, as we all know. So we need to separate them. So for us to do it, instead multiply both sides by the t. Multiply both sides by the t, you have the t multiplied by the p over the t equals to kp dt. So this cancel this. So I have dp equals to the p equals to the key, this one, the t. Then divide both sides by p. So if you divide both sides by p, you have it to be the p over p equals to kp dt over p. This one go with this. At the end of the day, we have integral of 1 over p dp equals to integral of k dt. So here we have ln p equals to k kt plus c. So we are looking for p now. We can take the exponential of both sides equals to exponential kt plus c, which is the same thing as exponential kt dot c. So in this case now, we have p to be equals to c exponential kt. So it simply means that p of t is equals to c exponential kt anytime, any day. So at the point 0, what happened? At point 0, what happened? When we have our t to be 0, what do we get? We said at p of 0 is equal to c exponential k of 0, which implies that p of 0 is equal to c. P of 0 is equal to c. Therefore, you can say P naught is equal to C. P naught can be, that's the initial P. That's the meaning of P naught. Initial population, which implies that P of t is equals to P naught exponential kt. But now let's look at the example. Let's look at the example. The table below shows that, let's look at the example. They can give you this question. The table below shows that, or show the rabbit population on a certain island where t is the number of years beginning with the year 2000. Number one, they ask us to calculate A. Determine the relative growth rate. B, write a general equation for the population P of t. Then C, estimate the population in 2010. D, how many years will it take for the population to double? Here is the table they are talking about. Year 2000. Remember they said it begin with year 2000. 1,500 population. No, sorry. 2001, 15,077. 2002, 16,000, 16,558. 2003, 1743. 1743. 2004, 1832. 2005, 2005 will be 1926. So we're asked to solve this problem. So it's pretty simple for us to do that. Remember, we have our P up here before. If we go to this place, you know, this is our general equation. Our general equation is this way, is this one. This is our general equation. Okay, let me just. The general equation is this. So if I have this one as my general equation, should be able to solve this problem. So in this case now, what is our PT? Remember, solution now. To solve it, let's look at it. We have P of t to be equals to P naught exponential kt. Then our P of 0, in this case, the initial year 2000 that we started from is 1,500. Then we have P of t to be, and when the year start from 0, we have 1,500 to be equals to P naught exponential k of 0. At the end of the day, we have P of 0 to be equals to P naught. Because 1,500 is P of P naught. So P of 0 is equals to P naught. So now we can justify by saying P naught, P of t is equals to 1,500 exponential kt. Then we know that P of 1 at the first year now will be 1,577 is given on the table. So which implies that 1,577 equals to 1,500 exponential k of 1. So when you divide through both sides by 1,005, you have 1.0513 equals to exponential k. Then we need k. So we have lane 1.0513 equals to lane exponential k. So at the end of the day, we have it to be what? The lane of this one will be 0.05 equals to k. So when we have 0.05 equals to k, then we can proceed. We can proceed by saying that P of t is equals to 1,500 just a minute. So P of t is equals to 1,500 exponential 0.05 t. Please just hold on. I think one of the students is coming. Memuna, are you there?
I'm here, sir.
Okay, which ID did you use? Why your own enter? I don't know why others are complaining.
I went through my portal. The ID there.
The one in your portal, is it not the same
Yes.
thing I share on the link?
That is what is the same thing.
So why is it difficult for them?
Maybe is it because I went through the portal? I didn't went directly. I don't know, but I used the ID.
Please put it on the chat. Are you on the WhatsApp?
Yes.
Please put it there.
Okay.
Maybe I will need to create another one. I don't know. But the link on the portal is the same link.
It's the same link. I don't know why it's not working. It's already there, man. It's already in the WhatsApp. It's already on the WhatsApp.
Is it not the same thing on the WhatsApp?
It's the same thing. Somebody has placed it there.
And you can still share it. Just tell them the way you go about your own.
Okay. Take it out.
Okay, excuse me. Let's continue because can you see the screen, please? Can you see my screen? Yes. Memunat. Are you there? Okay, let's proceed from here. So our PT is equals to this. We have our K to be 0.05. Then for C, we have calculated A and B. C now said, when your P is equals to, when your small t is equals to 10, what happened? So we have 1,500 exponential 0.05, 10. Then we have P of 10 to be equals to 2,473. So you can calculate it. So they now ask us again that for D, how many years would it take for the population to be double? Remember, initial population was 5. So how many years would it take it to be double? So let's do that one, double 2. For it to be double, we take, so it's going to be 300 So it's going to be, D will be 3,000 equals to 1,500 exponential 0.05 T. If you divide both sides, you have 3,000 divided by 1,500 equals to exponential 0.05 T. So here we have lane 2 equals to lane exponential 0.05 T. So at the end of the day, you have lane 2 equals to 0.05 T, and our T will be lane 2 divided by 0.05, which is equals to 13.86 years, approximately t equals to 14. So it will take 14 years to be able to double the population. Any question on this? Are you there, please? Wow. So Memonat, can you hear me? Let me stop here.